So, hello and welcome to the segment number 5 of the Geographical Peculiarities of Kuttanad Environmental Issues and Solutions course. Till segment number 4, we have been discussing about the geographical peculiarities of the place, some of the problems associated with the flood, some of the flood mitigation adaptation measures, and then we finally in the last segment number 4, we discuss about a particular project which is the Alappuzha Canal Rejuvenation Project, in which an environmental issue of the Alappuzha town has been attacked and a probable solution has been found out, and that is being executed right now in the city of Alappuzha. Maybe in another say a few years time, Alappuzha will be one among the best cities which practices the best wastewater treatment methods also. Now, getting energy or gaining energy from the Alappuzha Canal Rejuvenation Project, we went into Kuttanad. The Powam Canal and the Thumbooram, they are the canal as well as the place Thumbooram, they are part of Kuttanad only. They are part of the Nirmadi Panchayat in Kuttanad. So, we tried to clean a canal which is known as Powam Canal in Nirmadi Panchayat within a single day with people's participation, and then we tried to construct the compound wall surrounding the Kidake Thumbooram Padashekaram, which is of length 3.8 kilometers, using the debris, using the clay, using the deposits in the water bodies over there. So, that was the case study number 2 and 3 which are going to be discussed in this segment number 5. So, here we go. First of all, we shall see the Powam Canal experiment. So, Powam Thoda or Powam Canal is a canal having a length of 2.5 kilometers, which is running through the Nirmadi Panchayat. It suffered from silting and encroachments, of course. So, the canal is almost dead because of the kind of silting. The flow of water through that is almost not there, and there was a lot of encroachments also. So, there was a people's participation movement along with the Canal P, along with the engineering college over there and other concerned persons to clean the canal and to rejuvenate the canal with the energy obtained from the Alappuzha Canal rejuvenation. So, what we did is as in the case of the Alappuzha Canal system, the physical features like dimensions of the canal, depth of the silt deposit, encroachments, location of valves where water could be run off from the canals, dumping places for silt and weeds were collected through OSM tractor. That is also a kind of an mobile application through which we can collect it. So, just walk through the canal and collect these details like a reconnaissance survey only. So, the students from institutions were employed for this, and they were much interested in doing this for sure. And finally, on one day, the people's participation was there to clean the canal. So, social process including awareness program was exercised with the help of the local bodies, the Panchayat of Nirmadi. And then 1,500 Mahatma Gandhi Rural Employee Guarantee Scheme workers and the local people, guided by the by the engineers of KILA, the Kerala Institute of Local Administration, and Canal P. Canal P is a movement of engineers in Alappuzha. The full form of that is Alappuzha can do it. That is the full form of Canal P. Facilitated this desilting and strengthening of the bund of the canal. So, the debris from the canal has been removed, the desilting has been done in the canal. So, that slope has been maintained in the canal as it is done in the Alappuzha canals. And using the debris which is collected, using the silt and clay which is collected from the canal, the side bund has been protected. But without any kind of methodology, simply the collected waste was dumped into the canal side bund, and side bund was strengthened because of that only. Then A much more bigger project has been taken, like the Thumbooram pilot project. It is called as a pilot one because the knowledge which is gained from this project is now going to be imparted, and that is going to be employed, that is going to be implemented in the other Padashekarams also, in the other polder walls also. So, the purpose of this project is to first of all measure the water bodies which are surrounding the kind of Padashekaram over there. You can see in the green color the Padashekaram or the polders, the paddy fields, and surrounding the kind of triangular polder you can see water bodies. Water bodies are shown in blue color in the diagram. So, the water bodies, there was also silt deposit, somewhere the width of the water body was not sufficient, somewhere the flow was not there. So, a lot of problems were there. Weeds were there, lot of water weeds were there. So, removal of water weeds was also an issue. So, survey has been done in the water body surrounding this particular polder. The measurements like width of the canal or the river, whatever is surrounding that is taken. Depth of the water in the canals, depth of the siltation in the canal also were taken, following the methodology which was adopted in the Alappuzha Canal Rejuvenation Project. So, this is exercised over a length of, say, at every 25 meter interval, this measurements were taken, and the quantity of sludge to be removed was calculated, and this implementation has been handed over again to the irrigation department of the state. So, you can see the measurement, the numbers are given there. 135 acre was the extent of the paddy field of this Thumbooram Padashekaram. 3.5 kilometer was the length of the outer bunch. 300 meters is the length of the inner bunch. So, that is the quantity, and then the data collection process included flood level mapping using the GIS based tool, then topographic survey using a dumpy level, calculation of volume of sludge to be removed to ensure gravity flow through the water bodies, then say the mapping of other infrastructure, say bridges which are available there, other encroachments which are there, etc. Mapping of obstacles which are there in the water bodies, socio-economic sample survey, etc. So, those things were part of the survey only. This is also gaining knowledge from the Alappuzha Canal Rejuvenation Project. Then it was observed that the width of the canals vary sharply at occasions only, and there are plenty of encroachments, and the total sludge volume to be removed was 3.3 lakhs cubic meter, as you can see from there. That was the quantity which was collected. And then the main objectives of the silt and weed removal and the bund construction. So, once the silt and weeds were removed from the particular water bodies, the silt could be made use of to reconstruct or to strengthen the bund which is surrounding the canals or the water bodies. But when you do that, the bund also was observed that in some locations of the bund there is probability or the possibility of breakage, because fissures were there below the bunds. Water was actually penetrating through the bunds and flowing into the polders on the other side. And people also observed that in certain locations there is a possibility of bund breakage. It happens every year. So, the parameters of the bund also were collected, like what is the actual width of the bund, what is the actual depth of the bund, what is the material by which the bund is constructed, and then the debris as well as the clay and silt collected from the canals as well as the water bodies were made use of to strengthen the canal bunds, and a methodology has been formed after that. So, here what you see in the figure, the figure below is the correction of the canal profile. As in the case of the Alappuzha Canal Rejuvenation, you can see there are some troughs as well as peaks when you draw a graph between length of the canal in the x-axis and the reduced level of the center of the canal on the y-axis. So, all those troughs are to be cut off, and that is how the volume is arrived at, the total volume to be removed. So, with this 3.3 lakhs cubic meter of volume of sludge is made use of to strengthen the bunds. That is what is going to be discussed in the next slides. So, people participation was there, and community given agro enterprise also. So, these are all the associated aims of the project, what is given there. Now, how the Thumbooram project has been executed, that is what is being explained in this particular slides. Objectives: to collect soil samples and test for index properties of soil as well as CBR. So, these are some technical terms which are associated to civil engineering, because when you actually make a road or make a foundation or make the soil as the soil below the foundation, then the index properties are required, like liquid limit, plastic limit, etc. are required, and CBR is California bearing ratio, that is a full form of CBR. So, CBR test is conducted in the laboratory using the disturbed soil collected from the site, and the improved, say a higher value CBR indicates that the soil is good, a lower value CBR indicates that the soil is bad. So, that is how it can be interpreted. So, what we have done is we have collected the samples from the site, then as it is available, whatever soil is available from the site, that is tested for CBR, and we got a very low value for sure. And then we have added Kyer geotextiles into that in a single layer, multiple layers, and then the CBR test is done again, and the result is given in the coming slides in detail. So, from the data of the survey and the test results, to design suitable pavement using silt, clay and Kyer geotextiles based on gradation of the geotextile for sure, based on density of the geotextiles and based on the CBR value. So, a methodology has been devised after reinforcing the clay available from the site using Kyer geotextiles. That is what is being explained. To strengthen the existing bunds through the device methodology, geotextiles and Cocolog. Cocolog is a product which is produced by the NCRMI, Thiruvananthapuram. So, there is a Kyer Research Institute in Thiruvananthapuram, they are producing this Cocolog also, and this Kyer geotextiles are products of the Kyer board. So, they are available in plenty, and Kyer is also a product of Alappuzha for sure. So, it will be a promotion for that too. So, the Kyer geotextiles as well as the Cocolog. Cocolog is actually a bundled shape of this Kyer geotextile, I would say. Like in the shape of a cylinder, they bundle it, and these bundles could be inserted into the driven poles. In between the bund and the driven poles, the Cocolog is inserted firmly, and they help growing of vegetation. Finally, after some time, after say 2 years or 3 years or 4 years, they may this Cocolog or the Kyer geotextile may peel off from the place, but the vegetation will grow there, and the roots of the vegetation will keep the soil firmly. That is a fine line, right. So, after taking all those measurements and after conducting all those tests, the result is this. From the experimental results, it was observed that there was 53% of silt in the sample which is tested, 18% of clay and 29% of soil having higher gradation. So, silt, clay and other gradation say soil parameters, other gradation soil particles were there in that mix of soil. It was inferred that the strengthening can be effected through compaction, right. But added with this, if you add Kyer geotextiles as reinforcement, then you can further improve the strength of such kind of a soil. The California bearing ratio value of the silt clay mixture was found to improve when geotextile layers were added. It was inferred that bund constructed with the silt clay mixture and multiple layers of Kyer geotextiles would improve the strength almost 5 times than the ordinary bunds. So, that was observation. So, in the laboratory, if you get 5 times higher strength for a Kyer geotextile reinforced clay, then in the field if you do it, then you may get at least 2.5 times or 3 times strength for sure. The dry volume of the silt clay mixture was observed to be 36% less than the soil which was collected. So, this is incorporated in the design of bunds. So, these are civil engineering parameters, geotechnical engineering parameters. So, they were taken care of very precisely in the final methodology for bund construction. A typical cross section of the existing bund is like this. You can assume a trapezoid typically, but it may not be a trapezoid always. There is a side slope for sure. Side slope is close to 70 degree. It was observed like that. The top width was close to 1.5 meters. It varies from 1 meter to say 2.5 meters in some locations. Sorry, the height is 1.5 meter. The top width is 3.5 meters. 3.5 meters. Somewhere it varies from say 2.5 meter or 2 meters to 3.5 meters. And the bottom width of the bund is close to 4.6 meters, having a slope of 70 degree on the sides. Area of cross section thus comes out to be some 6.072 square meters. This is a typical cross section only, but when we went to for measurement in other places, it varies. And such kind of a typical existing bund is improvised in this manner. You can see the top width is maintained as 3.5 meters. The bottom width will increase because there is a side slope for sure. And Kaya geotextiles are going to be made use of to improvise this, and that is going to be explained in the coming slides onwards. So, the numbers are like, if the bund which you see in the previous slide, if that is to be improved, the improved bund looks like this. The top width is 3.5 meters, thickness of additional construction, thickness of additional clay is 0.75 meters or 75 centimeters. Then side slope with respect to the horizontal is 70 degrees. Cross sectional area is improving to 3.645 square meters. The bottom width of bund is increasing to 5.14 meters from 4 point something. Then total height of the bund is increasing to 2.25. This is only a typical example. So, depending upon the availability of the existing bund, there is modification to this kind of a design. So, this has been actually proposed as a typical design, and that is after sufficient modification, that is accepted in other places also. So, this is how the reinforcement is being done. The cross section of bunds strengthened by Kaya geotextiles, you can see that the colored portion in the figure is the existing bund. Covering that, we place a geotextile layer, and that geotextile layer extends to the side walls also. So, side wall is protected just like that, and then along the side walls we add more clay, so that sufficient width is maintained. And then covering that, another layer of geotextile is going to be placed on the side walls only, and then it is going to be explained in detail in the further figures in the coming slides, but still I am just trying to explain. A third layer of geotextile is going to be placed on top of that layer of geotextiles, and that is going to be taken to the top and ballooned. So, the ballooning process is going to be explained in detail in the coming slides. Now, we can see there are three layers, three white layers of clay is shown in the figure. The clay layers are laid one by one, one after the other. After laying the third layer of geotextile in the original surface, we put a layer of clay having a thickness of 25 centimeters. That is rammed using natural rammers available there. So, water will go off and it will undergo some amount of compaction, and then a second layer of geotextile is placed above that as a reinforcement. As you can see, the red colored line represents the geotextile layer. Above that, so when the geotextile layer is placed, it is placed so that the geotextile is in a tensioned state. There is nothing is in a slackened state. So, the geotextile will be in a tensioned state, and above that second layer of clay will be placed of 25 centimeters thickness and rammed further, so that the net height is 25 centimeters. Then another layer of reinforcement geotextile layer is placed, and a third final layer of clay layer is placed, rammed, and the geotextile which is laid in the original bund, it is ballooned up, it is folded up. You can see from some photographs how this is done in precisely. So, it is taken to the top and stitched on the top in a tension state. It is not going to be in a slack state. So, this is what is done precisely. Layer by layer is shown in figures, as you can see there. the figure on the left, we observe that on the bottom you can see a trapezoidal shape original bund. On the side we place on top you can see, on top of that you can see a layer of geotextile which is going to be placed on the original layer, and then soil is going to be placed on the side of that, and then a ballooning geotextile layer is placed just above that. You can see a upward curved geotextile layer. Then above that there is a layer of clay, then above that there is a layer of geotextile which is horizontally placed. Above that a second layer of clay, then above that there is a layer of geotextile which is again a reinforcing layer, and above that the last layer of geotextile, and the ballooned geotextile from the bottom is taken to the top. What you see on the top is the part of the geotextile on the bottom itself, that is ballooned up and it is stitched on the top tightly. That is how it is going to be done, and it was successful. So the methodology is explained in detail over here. The quantity of silt clay mixture required to enhance the height of the bund was 0.75 meters for 1 meter length. It was 3.64 cubic meter. That is a kind of a quantification. So you can find out the quantity required for say 1 kilometer or say 3.85 kilometer, just like that. It is expected that the total volume shall shrink by 25% to 30% from experiments after evaporation of water. That is why finally we require a total height of at least say 60 centimeters. So, but we put the rammed layers of clay in such a fashion that the total thickness is 75 centimeters, and finally after draining of water the thickness becomes like 60 centimeters. Based on the test results of California Bearing Ratio or CBR and IRC code, Indian Road Congress Code 37 2001, the thickness of the pavement required is 45 to 150 for 45 to 150 vehicles per day. That is the least number of vehicles, that is 0.6 meters. That is how the number 0.6 was arrived at. So we assume that the clay which is placed above the original bund is like a pavement. So it is designed like a pavement only, and accordingly, according to the IRC code for road design, we have designed the kind of a pavement. And the number of vehicles is not going to be 45 to 150 vehicles per day for sure, but the vehicles of the local people could be now run through that road for sure. The width of bund shall be increased by 0.271 meters to either side on the bottom to maintain sufficient side slope. So this is also a typical figure. That figure may change depending upon the original bund over there. Further, continuing with the methodology for strengthening the bund, coir geotextile of 10 meter length. So this is how we find out the final. We have to find out a final methodology and give it to the workers over there. So coir geotextile of length 10 meters and width 2 meters. That is cut in that particular dimension and laid along the width of the bund to reinforce protection of the existing bund. That is the first layer, and then after adding soil to the sides of the bund to ensure adequate bottom width and side slope, the coir geotextiles shall be anchored to the bottom of the canals and paddy fields using bamboo nails. That is what is very familiar to the MNREGA workers over there, and they will be doing it very nicely. But the ballooning process, reinforcement process, those were not familiar to them. So we have to actually teach them to do this. Then another layer of coir geotextiles shall be laid on top of the first layer of almost of the same dimension, say 10 meters of length and 2 meters of width, to cover and protect the additional layer of silt and clay on the top. Silt clay mixture which is dried for 24 hours shall be laid to a thickness of 25 centimeter and compacted. Coir geotextile of 2 meter width, reinforcement shall be that is used as reinforcement, that is shall be laid above this along the length of the bund. So this is how the methodology is explained in detail. Further, if you go further, the second layer of silt and clay mixture shall be laid above this for another depth of 25 centimeters and compacted, manual or using rollers. Another layer of coir geotextile of 2 meter wide reinforcement shall be laid above this along along the length of the bunch. Now, the third layer of silt clay mixture, which is of 25 centimeters thickness again, shall be laid above this and compacted manually or using rollers. And further, the Kaya geotextiles which were laid below shall now be raised to the top of the bunch to balloon the layers of silt clay filling and tightly anchored using bamboo nets on top. The side slope shall be maintained at 70 degree. Now, finally, after doing this, a 15 centimeter thick layer of gravel can be placed above this to facilitate traffic later. Now, again it has been explained through the figures, dimensions of the typical bund cross section. So, these are some numbers which you can go through in detail. This is already explained in the previous slides for sure. You can see a 3-dimensional picture just to explain to the workers that A will be just like your original bunch, and B is the additional thing which you are doing, that is it. So, the dimensions are pretty clear using this particular figure. You can see the execution of this. The initial layer of clay has been laid in the original bunch after protecting the original bunch as well as after laying the geotextile layer. You can see different stages of laying of clay in the existing bunch to bring the bunch to a shape. Geotextile layer is being laid by the workers over there, you can see that also. Yeah, the first layer of geotextile layer is now complete in that particular portion. Then anchoring of the geotextile to the canal as well as to the paddy field on the other side. Yeah, it is another photograph of that. You can see the anchoring of the geotextile again on top. Further, second layer of clay is laid directly taken from the canal with the the equipment over there and laid on the canal top, and it is rammed. And on top of that, a layer of geotextile is laid as reinforcement. So, different stages are being given in photographs. You can see another photograph over here. So, finally, the finished road looks like this with the geotextile on top, and further above this a 15 centimeter thick gravel also will be laid. So, this has been successfully completed. In fact, this has started on 8th of February 2020, and after that this lockdown came into existence. So, we could not complete that in time because of restrictions laid on by the lockdown. But later, after several months, it has been completed and now it is open to public. So, this is the experiment which is done in the Powam Canal as well as in the Thumbooram polder. Thank you.